From Department of Computer Science and Engineering, I would like to welcome all for video lecturer on Cyber Security course with Anna University syllabus on Regulation 2021. Unit 5 in Cyber Security course is Intrusion Prevention. The topic is firewall location and configurations. Generally, firewall is positioned to provide a protective barrier between an external source of traffic and an internal network. With a general principle in mind, a security administrator must decide on the location and on the number of firewalls needed. Next is DMZ networks, that is a common firewall configuration that includes an additional network segment between an internal and an external firewall. An external firewall is placed at the edge of the local or enterprise network just inside the boundary router that connects to the internet or some wide area network. One or more internal firewalls protect the bulk of the enterprise network. Between these two types of firewalls or one or more network devices in a region referred to as a DMZ network, that is demilitarized zone, and the systems that are externally accessible but need some protection are usually located on DMZ networks. Typically, the systems in the DMZ require or foster external connectivity such as a cooperative website, an email server, or a DNS server. See the diagram. This is an example of firewall configuration of DMZ network. Here it contains internal DMZ network and internal protected network, also the boundary router, external firewall, LAN switch, and internal firewalls. The external firewall provides a measure of access control and protection for the DMZ systems consistent with their need for external connectivity. The external firewall also provides a basic level of protection for the remainder of the enterprise network. In this type of configuration, internal firewalls serve three purposes. Like the first one is the internal firewall adds more stringent filtering capability compared to the external firewall in order to protect enterprise servers and workstations from external attack. The next one is the internal firewall provides two-way protection with respect to the DMZ. First, the internal firewall protects the remainder of the network from the attacks launched from DMZ systems. Such attacks might originate from worms, rootkits, bots, or other malware logged in a DMZ system. Second, an internal firewall can protect the DMZ systems from the attack from the internal protector network. Multiple internal firewalls can be used to protect portions of the internal network from each other. Then the figure shows a configuration in which the internal servers are protected from internal workstations and vice versa. It also illustrates the common practice of placing the DMZ on a different network interface on the external firewall from that used to access the internal networks. Next is virtual private networks. In today's distributed computing environment, the virtual private network offers an attractive solution to the network managers. In essence, a VPN consists of a set of computers that interconnect by means of a relatively unsecure network and that makes use of encryption and special protocols to provide security. At each corporate site, workstations, servers, and databases are linked by one or more local area networks. The internet or some other public network can be used to interconnect sites, providing a cost savings over the use of a private network and offloading the wide area network management task to the public network provider. That same the public network provides an access path for telecomputers and other mobile employees to log on to the corporate systems from remote sites. But the manager faces a fundamental requirement security. Use of a public network exposes corporate traffic to eavesdropping and provides an entry point for unauthorized users. To counter this problem, a virtual private network is needed. In essence, a virtual private network uses encryption and authentication in the lower protocol layers to provide a secure connection through an otherwise insecure network, typically the internet. The VPNs are generally cheaper than real private networks using private lines but rely on having the same encryption and authentication system at both ends. The encryption may be performed by firewall software or possibly by routers. The most common protocol mechanism used for this purpose is at the IP level and it is known as IPsec. The diagram is an virtual private network security scenario. The figure is a typical scenario of IPsec usage. An organization maintains LAN at dispersed locations. Non-secure IP traffic is used on each LAN for traffic offsite through some sort of private or public bands. IPsec protocols are used. These protocols operate in networking devices such as a router or firewall that connect each LAN to the outside world. The IPsec networking device will typically encrypt and compress all traffic going into the WAN and decrypt and uncompress traffic coming from the WAN, that is wireless area network, and the authentication may also be provided. These operations are transparent to workstations and servers on the LAN. Secure transmission is also possible with individual users who dial into the WAN. Such user workstations must implement the IPsec protocols to provide security. They must also implement high levels of host security as they are directly connected to the wider internet. This makes them an attractive target for attackers attempting to access the corporate network. A logical means of implementing an IPsec is in a firewall as shown in figure. If IPsec is implemented in a separate box behind the firewall, then VPN traffic passing through the firewall in both directions is encrypted. In this case, the firewall is unable to perform its filtering function or other security functions such as access control, logging, or scanning for viruses. IPsec could be implemented in the boundary router outside the firewall. However, this device is likely to be less secure than the firewall and thus less desirable as an IPsec platform. Next is distributed firewalls. A distributed firewall configuration involves standalone firewall devices plus host based firewalls working together under a central administrative control. That the figure suggests a distributed firewall configuration. Administrator can configure host resistant firewalls on hundreds of servers and workstations, as well as configure personal firewalls on local and remote user systems. Tools let the network administrators set policies and monitor security across the entire network. These firewalls protect against internal attacks and provide protection tailored to specific machines and applications. Standalone firewalls provide global protection, including internal firewalls and an external firewall, as discussed as previously. With distributed firewalls, it may make sense to establish both an internal and an external DMZ. So, the web servers that need less protection because they have less critical information on them could be placed in an external DMZ outside the external firewall. What protection is needed is provided by host based firewalls on these servers. An important aspect of a distributed firewall configuration is security monitoring. Such monitoring typically includes a log aggregation and analysis, firewall statistics, and fine grained remote monitoring of individual hosts if needed. Thank you.